Thank you. Thank you. Thank you, Mr. Keys. So, one of the reasons why we believe that this training is important and we're happy to be here with you today is that because we believe that SIMPLIS is the best simulation tool for switching power supply design and analysis. And the reason is because SIMPLIS is the best power supply simulation tool for AC analysis, including Bode plots and things like input and output impedance. And then also for loss analysis, looking at switching losses in MOSFET and the MOSFET drivers. And now, as of version 8.4, we do a really good job with magnetic losses, and we'll show you a very brief demonstration of that today. In addition, SIMPLIS is great for transient analysis, for things like step load and step line analysis, but it's also good for robust feature design, such as current limit parameters and dead time optimization, that sort of thing. And then later today we'll talk about digital control, because SIMPLIS is really good at digital control. So what I'd like to do is maybe just show you quickly some examples of this. Okay, so here we have a synchronous buck circuit, and here we have it hooked up to measure a Bode plot. And so we have a nice little example circuit that shows you how to do that. And our analysis is set up to find steady state and do the AC analysis. And so SIMPLIS can find the steady state quite quickly, and then also we can do the Bode plot. So let me adjust this a little bit. So, okay. Okay, here we go. And we'll tighten that up a little bit. So this is your typical Bode plot, and SIMPLIS is really good at this, very, very good at this. But it also is helpful for things like input impedance. So here we have an example circuit that shows you how to take the same circuit, but now we're measuring input impedance. So we're looking to see, we're injecting an AC signal and then measuring the input impedance. And again, SIMPLIS does a great job of that. Okay. So here we can look at the impedance in dB, so gain and phase. Also output impedance. So looking, we have the same circuit, and we have a little demonstration circuit here that shows you how to measure output impedance. And SIMPLIS does a really good job of that as well. Okay. Because the injection point is different in each circuit, you have to have a different measurement set up for that. Okay. So here we're looking at the output impedance and gain and phase for that. SIMPLIS is also really good at things like phase lock loops, switching systems. So here's a phase lock loop, and we'll measure we'll find steady state, and we'll measure the loop gain of the phase lock loop. SIMPLIS is, let's see, let's do close all this. All right. So the other thing that SIMPLIS is quite good at is Class D amplifiers. Again, it's the same kind of circuit. It's basically a synchronous buck, except instead of the reference being constant, the reference is an audio signal. So here we have, here you can see the power switches here and the LC filter on the output, and then we have the gain. So here is a analysis of an audio amplifier, Class D audio amplifier, and you can see that the gain is constant and flat out to about 20 kilohertz. So SIMPLIS has a lot of uses in addition to switching power supplies, but switching systems it's really good at. So if you send an email to Intragritech and ask Mr. Keys, he can send you all of these example circuits if you like. Some of them are pretty helpful. For example, as we'll find out very soon, SIMPLIS assumes that everything is switching, but when you want to measure the impedance of a capacitor, that's a passive network. So we end up making it a switching circuit using this little technique. So here's an example of how to measure capacitance impedance for a pure capacitor, capacitor with ESR, a capacitor with ESR and ESL. And this can be very helpful. We get a lot of tech support about how to do this. So here's the impedance of a pure capacitor. Here's the impedance of a capacitor with just ESR. And here's the impedance of a capacitor with ESR and ESL. All right. We have a similar circuit for finding the impedance of an inductor. And so we have the impedance of a pure inductor, which just starts very low and goes to very high. That is not the best way to model inductors in SIMPLIS. It's much better to include ESR and to include a shunt resistance. This is a much more realistic approach, and this is with our lossy inductor, and we'll talk more about this later. Okay. All right. So we're very good at doing AC analysis in switching systems. SIMPLIS is also really good. Oh, wait a minute, that's the wrong one. We're very good at analyzing switching losses. So here's a test circuit, and we won't go into detail here, but here's a test circuit with a MOSFET model. And this test circuit has been very carefully designed to have identical drive and load characteristics for both symmetric SPICE and SIMPLIS. So when I double click on this, I start off doing a SPICE run. So we're doing a SPICE run, and now we're doing a SIMPLIS analysis. So here we have the waveforms, the drain to source, gate to source, and gate current, for example. And you can see that the waveforms between SIMPLIS and SPICE are almost identical. There's a little bit of difference if you zoom way in, okay? But if we look at the loss characteristics, sorry. If we look at the loss characteristics, here we are measuring the turn-on loss. Here we're measuring, the conduction losses. And here we're measuring the turn-off losses, and then this is the total. So this is the total energy lost. And you can see that they're extremely close, all right? And here's the power loss. You can see that, again, they're extremely close. So if you do a careful job of modeling the circuits, SIMPLIS can do an extremely good job of modeling switching losses, okay? All right. Now I have one other loss example that I'd like to show you, and I'm going to show you that in our new 8.4 version. Okay, so here we have a simple synchronous buck, but in this case I'm going to zoom into the inductor, which is a lossy piecewise linear inductor. So at model level 0, you can define the piecewise linear characteristics. Model level 1, we add ESR, but in version 8.4, we will be offering a magnetics design module. And here, when you click on this tab, you'll be able to pick a core structure, you'll be able to pick a core material, you'll be able to design where the windings go in the window, you'll be able to define the cooling. In this case, it's set up to natural convection where the ambient temperature is 25 degrees C. But you'll be able to define the physical characteristics of the inductor or transformer. And then when we run the simulation, we'll first calculate the waveforms. And then, based on these waveforms, we'll calculate the losses in the magnetics, including the winding loss and the core loss. Here we're looking at the proximity effect losses. Here we're looking at the skin effect losses. And then down here we're looking at the DC winding losses. Okay? So we can also look at the losses per turn. All right? And in this case, you can see that the difference between the losses in this turn, in this wire, which is 10 watts per cubic centimeter, compared to the loss in this wire, which is 5 watts per cubic centimeter, we can see that these turns, and this one in particular, are much, this has twice the loss of this turn, all right? And the reason is that because it's very near the air gap, we have fringing flux that goes around the air gap. It doesn't all go straight through. Some of it goes around the air gap, and this flux, this changing flux, creates eddy currents in the copper, and that generates extra losses. So these windings will be hotter because they're in close proximity to the air gap. And you can do things like, we'll plot inductive current. The point for the moment, though, is that we do a very good job of modeling magnetics losses. As of, is when the magnetics design module is introduced as part of our 8.4 product rollout. Okay. All right. So we can close that for the moment. The other thing I just wanted to show you very quickly is that we have some really cool, helpful tools where, because SIMPLIS is so good at so many different things, one of the things, in this case, everybody has a design, everyone has a design, spreadsheet that has your design equations in it. And so I will show you one that we just put together. And it's right here. Okay, so right here. So here we have just a little spreadsheet that we put together to help us calculate the compensation network for a type 3 compensation scheme. So we're trying to calculate all of these values based on the values in the power stage. So we know what the inductor is, we know what the capacitor, the ESR, and the input voltage, output voltage, etc. All right. So we have that information, and so now we have a very cool feature where I could just click this button and it will generate it'll copy my original schematic, generate a new schematic that now has all the calculated values that I did. So if you see my initial schematic, the value was 5.3. Now it's, you know, a calculated value. And you're also able to calculate values and populate values inside of a subcircuit. So you drill down and go in here. So because these are some of the reasons that we just think that this, you know, SIMPLIS can be a really valuable tool for, you know, for designers in switching power supplies. So all of these example circuits you can get via email if you just send an email to Mr. Keys at Integratech, okay? All right? So, good. So now what we'd like to do is we're going to get started with the formal part of the course, all right? So what I'd like you to do, and let me see if I have my PowerPoint thing. Yes. So what I'd like you to do is first create a new directory on your laptop and just pick like C and make it training. So create a new directory because we're going to put some example circuits in there. All right. So maybe, John, Dami, you could tell me when you think people are ready. Okay, so we want to go to C, you know, so you want to create a new directory, C training. Are we good? Look good? And then in your browser, so Windows Explorer or Firefox, whatever you have, your browser, go to simplis.com and you should see this page, all right? So navigate in your browser to simplis.com, okay? So if you just type simplis.com up here in the URL window, it should take you to this page. So how many people are at our website? So from the website, I'd like you to click on this link called support. So from the website, let's click on this link called support, and then we're going to go to product documentation. Okay, so first click on support and then product documentation. Okay, are we okay? So you should see a page that looks just like this.